Hello again. Now we're going to use radians to find a sector angle or arc length, and you'll see this described on page 188 in your textbook. So there's a relationship that exists, a proportion, that we can use to find any missing piece of information. If we know the arc length, or at least three of the following four: the arc length, the circumference, the distance around the circle, the sector angle, and one revolution. If we know any three of those, then we can always find the fourth one. Well, we know what one revolution is. That's always going to be 2 pi. And we know what the circumference is. That's going to be 2 pi r. So the arc length and the sector angle we can figure out. So let's take a look at a first example. In this example, we know that the radius is 10, and we know that the sector angle is 1.7, and we're asked to find x. So we can plug in the information into that proportion. The arc length is going to be x. The circumference is going to be 2 times pi times the radius, which is 10. That's going to equal the sector angle, which is 1.7. And the revolution is simply 2 pi. Well, if you multiply both sides by 2 pi 10, that's going to be gone. Here you'll have 2 pi and 10, and the 2 pi cancels with that 2 pi, so you're left with x equals 17. In this second example, it's theta that we're missing. It's the angle that we're missing. So we're going to put the sector angle piece first. So let's put our missing piece of information on top. That'll be divided by 1 revolution, which is 2 pi. It's going to equal the arc length, which is 6, over the circumference, which is 2 pi 4. Now to get the sector angle by itself, we multiply both sides by 2 pi, and you get theta is equal to 6 times 2 pi over 2 pi 4. Once again, the 2 pi's cancel. You're left with 6 over 4, or 3 over 2, or 1.5 radians. You don't even have to write radians. If you're measuring an angle and you don't show degrees, it's assumed to be radians.